Hi, so I'm Curtis. I'm the CEO and co-founder of Cleanlab. This is a pretty interesting company in the sense that we just started the company last year, but the work comes out of work that we've been doing for about 10 years. I did my PhD on Cleanlab at MIT, and then joined with two co-founders, Anish Athalieh and Jonas Mueller. Also did their PhDs at MIT, and they're good friends from the last decade. And we spent some time figuring out a new problem that sort of hadn't been focused on before, and that was how do you automate and automatically find errors in any data set? And I think this is particularly relevant to this crowd. Healthcare is known to have very noisy, very messy data. And this is what we do. And we open source everything. All our algorithms are online and we publish. We share the results that we're doing. And we have a SaaS product we're building that automates all of this. But the goal is, and this is very much from our MIT roots, to try to give to the community, to open source. And we believe in the transparency of the open source model. And it's mutually beneficial. You get a lot of good feedback. You can iterate with the community. So that's why we open source everything. And it's something we've been doing now for about half a decade, even though the company is actually pretty new. Although we're new, lots of folks use Cleanlab. Tesla uses it, Google, Amazon, and various versions, whether they use like one line of code from the open source, or we've done an integration with them directly. But we're quickly growing, and so I'll just share a lot about the open source. And I'll try to focus on open source for you guys because I think that's what you'll be most interested in, so you can use it, at your own companies. So let's just jump right in. And how does Cleanlab make AI work with messy real-world healthcare data? So if you're interested at all about Cleanlab, and sort of how does a grad student project turn into something that's used by some of the big tech companies around the world, there's a blog post. You can check it out. It's on our blog page, and I just put it out actually just a couple days ago. So it's brand new. You can read about it, see some fun history, how something like that actually happens. But let's jump into the content of the talk. So the sort of talk is focused on Cleanlab 2.0, which is a new launch that's coming out in the next couple of weeks, and you're getting a sneak preview. And that's open source, and then it's built on Confident Learning, which is research that we did at MIT. And then in this talk, I'll focus on sort of three examples. So one is labelerrors.com, which we'll take a look at. Two is industry, just general examples of how Cleanlab has been useful at various tech companies and just in general. And then lastly, some healthcare examples. And for those, I'll just sort of talk through them and show you how you could use the open source repo to solve those problems. So it'll be more of a discussion. It should be fun. And I think it'll be pretty relevant for folks working with messy data, especially labeled messy data. So let's jump right in. The first thing I want to show is this is when I was working in 2016. I was an intern, a young version of me, and I was at Facebook AI Research. I was in Jan LeCun's group. And for those who aren't familiar, Jan LeCun and Jeff Hinton recently won the Turing Award, which is like the Nobel Peace Prize in computer science, for their work in computer vision, detecting classification of images, and other things as well. I think Jeff Hinton is generally known like across the industry, and also across the field, and in many ways beyond just convolutional networks, which is how images are detected. But I was in Jan's group at the time, and Jeff Hinton came by, and he had this data set. He was working with Jan LeCun's MNIST data set, and he was excited to show us that he had found an error in Jan LeCun's data set, that there's actually this 5 that was like mislabeled as a 3. And I'm bringing this up because it's pretty fun, but also because just to make the point that some of the most brilliant minds in the field and some of the most respected thinkers on the topic of machine learning and data have been interested in this, and they were interested in even a single error. And so we sort of took that to scale at Cleanlab, and we thought, let's look at these data sets and see if there's more than one error. So back in 2016, 6 years ago, I started looking at MNIST, and it had been assumed for the most part in most publications to actually have no error at all. And so I was interested in saying, hey, is that actually true? And so, I've been building out Cleanlab, and we had published a bunch of papers with various folks, at MIT and at Google, and the co-founders at Cleanlab. And we had seen that, hey, we can actually build like a field that can detect errors automatically in data sets. And so we thought, hey, let's just run Cleanlab on MNIST and see if we can actually detect label errors in like one of the most common benchmarks in the field. And so we did that, and it turned out that MNIST actually had lots of label errors. So like in the top left, that's a looks like a 9. That's labeled 8. That's like a strange like 6 thing. That's labeled a 0. This sort of 3 looking thing is labeled a 5. And so then we started scratching our heads. We're like, wow, like these are the most curated data sets. And we seem to be able to detect them where, other tools in the past hadn't. And so we started to get some validation that this thing is not just theory in a lab at MIT. It actually, it seems to be working. And so we sort of took this at scale, and we ran Cleanlab on the 6 largest or like most commonly cited image data sets. And then also the 3 most commonly cited text data sets, and then audio data set. And we wanted to see like, hey, can Cleanlab find errors? And it turned out that actually we found millions of errors, and Cleanlab worked like pretty robustly. And so I'll just do a quick demo so we can sort of run through what that will look like. So hopefully you can see my screen. So this is labelerrors.com. You can check it out. And there's data sets up here. You can check out whatever you want. But this is ImageNet. And ImageNet is pretty common. And all of these are examples. So this is like a scorpion labeled a black widow spider. And this is a tick labeled, it's actually a scorpion. It's labeled a tick. You can check these out for yourself. You can also look at like different classes. And you can also look at, different data sets. So this is like quick draw. This right here is labeled t-shirt. It's like totally an apple. This is labeled flashlight. Definitely looks like a hockey puck about to get hit. This is supposedly a diving board. It's labeled a bird. So you can really see label errors are common. I think a lot of folks, especially in healthcare industry and in NLP, and the folks who are like attending this conference know, yeah, we have a lot of label errors. So let's go to a text data set, which is more relevant for this conference. So this is example a review, and it says this is a book of 1,300 tweets, humorous ones. It's like very, very excited and happy. But then there's neutral, and you can actually see if we just go to like, this is things that are labeled neutral. You can see all the examples that are errors, and you can also go to negative and see this is an example of somebody saying, oh, I wasn't really digging it, but then I finally got back home and I dove right in, and then I realized like it's actually good. And so you can just check these out for yourself. Some good ones from IMDb. So these are text data sets where we literally just ran them through Cleanlab, and used a couple lines of code, and we're able to find all the errors, and then retrain models which are more performant. In the case of Amazon, we were able to improve performance by like 5% on a final trained model, and you can check that out in the Confident Learning paper. So jumping back to the talk, so how do we actually find these label errors? I'll just share a bit about what we do and how it works. So you can use Cleanlab to just find putative, which are sort of like your candidate label errors. And then what we did in order to make sure that this thing works, it's one thing to like make a claim and say, oh, we found all these errors, and show them to you, and you can see they kind of work, but there are millions of them, and we're just showing a few. So we ran a human verification across all 10 of the data sets at scale at MTurk to double check and see if they looked reasonable. And for the most part, they were. And so that gave us a lot of strong validation. And this was, last year. And then we've been working more in the industry since. But I'll just share a bit about how does it actually work. So how do we actually find the errors? So there's a paper out called the Confident Learning paper, and it's about estimating uncertainty in data sets. And this is joint work that I did with Lu Jiang, who's sort of the head of noisy learning research. He's a brilliant researcher at Google, who I've been working with for the last few years, and he's a good friend. And then also Isaac Chuang, who's mostly known for his work in quantum computing at MIT, but he was my PhD advisor. And so we've been working and thinking about, from the information theoretic perspective, how can you think of a data set similar to how you would think of quantum information, where you have some noisy process that's perturbing the information, and you're trying to uncover it. So we think of a data set the same way. A data set has labels and data, and then there's noise. Some noisy process has caused that data to be perturbed and corrupted. So what we do is we estimate what that process was, and then we can reverse and uncover what the true data set was. And I'll show you how we do that. But we first of all, it's something that's really neat and unusual, I think, in industry, is we actually prove that this stuff works. And you can check that out in the paper. But for pretty noisy and messy models, we can still show that we can exactly find label errors. In practice and industry, most companies and models are so much more underperformant than theoretical guarantees. We'll still find errors. Or that we'll still have errors in our in Cleanlab, so it won't be perfect, but it will give you a lot of strong signal, and it will rank every data point for you. And so you can just try the open source, and you'll see like it will make some mistakes if you have a pretty messy model, or if your data is just like really noisy. It won't be perfect, but if you have like a pretty great model, if your model works pretty well, but you just have some like error in your data, you can get pretty close to perfect. There's also the algorithms are practical, like you can use them, and we'll show you some of the cases. And it's general, so no matter what your data set, conference is focused on NLP, but you can use Cleanlab also for image data. You might be a multimodal company or multimodal researcher, so you can use Cleanlab for any data set, any model, or any modality, and it should work. So just a brief background. So the way it works is we find systematic errors. So not just like random label flipping, which we can also detect, but we're interested in things that are sort of more realistic. So for example, a fox is like much more likely to be labeled dog than cow. Or in an NLP data set, you can imagine like you have tags, and the most related tags are more likely to be flipped. And so that's the way that we approach the problem. And we do that by making one assumption, which is that we assume that irrespective of the data, so this is a conditional independence assumption. For those who are familiar with, this is a sort of an introductory probability expression. And it's pretty simple. It's just saying, look, regardless of whether X is given the data, we can say that we can completely model the flipping rate of the true label to what you actually observe with just a single matrix. So you don't actually care what the data is. And what this is saying is that the flipping rate is conditionally independent of the data. Or in other words, you can use just this matrix here to fully characterize the noise. And that's what we do. And so we actually estimate a joint distribution of the noisy label and the true label. And then what you see is like along the diagonal, there's a lot of signal, and then the errors are on the off diagonal. So these, like, say you had 100 examples in your data set, then what this matrix would say is that we detect there are 5 examples that are labeled dog, but the actual image is like of a cow, or the actual text, or the your text label should have been cow, but it was labeled dog. And so that's how you can sort of read this joint. And what we do is we estimate this, and this is that noisy information process. So once you have this, then you can sort of uncover what your true data set is, and that's how Cleanlab works. So then we open source that, and we made it so that you can do that in just a few lines of code, and we'll look at that repo in a bit. So we ended up running this on all of those data sets I showed earlier, and then checking them, and we found that there were millions of errors guessed, and then we checked a bunch of them, and we were able to figure out that some of these data sets, like Quick Draw, for example, like 10% of the labels are wrong. And that's pretty significant. That will significantly affect your model's performance. When you clean those out, you can get a boost. And if it's a very small amount of error, you might not see any improvement. And if you remove too many examples, you might actually see a decrease in performance. So sometimes what we do, just as a practical standpoint and aside, we actually will only remove a subset of the errors found by Cleanlab. And that's a good way that you can get improvement without removing too much data. If you use our SaaS product, then we'll actually fix the errors, and that way you don't have to remove the data. But that's neither here nor there for the open source. So let's look at really quickly. There was a paper that we had out, pervasive label errors, and this was published in NeurIPS, and it talks about all the results that I just mentioned, and it's worth checking out. I recommend it if you want to see sort of how do we detect these things at scale, how does this stuff work, like in a very practical and applied way. This slide I'm going to skip for time reasons, but it shows how you might want to actually correct. I'll just show you very quickly, because it's fascinating for a company. If you guys have test data sets, why does it really matter to have sort of a good test data? So on the left, this is a trained model, and what we show is on the green, and what you observe, these are correctly labeled data, and then these are noisy labeled data. And so what we're looking at is a classifier, and what is the accuracy? And so this is a model that's been trained on this data set that has 100% test accuracy, because there's all the green here, and then there's only one red point here, and then all the blue is here. But the thing is that these are actually label errors, and so on the right is what's actually happening. And so the real world accuracy is much lower, but because this is a noisy label here, it looks like it's green because you just have the wrong label, but actually like it's a red example, and so it's actually wrong. And so the point here is just that if you don't use a corrected test set, in your benchmarks or at your company or however you're doing data, and this is the same for just like data analytics or inference, you're just going to get wrong statistics. And so that's why we use Cleanlab. That's our whole purpose, is to make data sets accurate and the labels accurate and the data accurate. And then you can do like lots of smart decisions or train better models or figure out which of your annotators made the most mistakes and stuff like this. Yeah, just let's jump ahead. So here's some example use cases. So if you remember in the very beginning, I mentioned that we look at some examples. So let's just jump into a few of those. So I spent some time at FAIR, as I mentioned, at Facebook AI Research. And what we were interested in there is using Cleanlab to correct biases, up and down votes for comment rankings. And I didn't end up doing too much of that using Cleanlab at Facebook. I ended up building out Cleanlab sort of after that. But I took some of the same ideas and we were able to correct biases and comment rankings for online courses for MIT and Harvard. And we published a bit about that. And the idea is you have a label, right? It's a up or down vote, and you have text, a comment. And so it's a very clear example where you have a noisy label and you have a way to find those errors. You can actually find them and then correct for them and get a better ranking. And we use it particularly for diversification. So like if everyone is all biased saying the same answer, how do you sort of find like that one person who has a different opinion and bubble them up to the top? I then the next summer I spent at Amazon, and I used Cleanlab to figure out when does the Amazon's Alexa device wake up and not wake up. And for example, this very specifically, like how would Amazon actually know when their devices don't wake up when you say the word Alexa? So they don't. And so what we did is we were able to use Cleanlab in order to estimate the noise, the true positives, the false positives, and the true negatives. And then we could figure out what were the false negatives. And so that allows us to estimate this false negative rate, which is very useful for their business because now they know all the times their devices don't wake up, and then they can use that as a metric to improve the model. And that's what they did. Then the next summer, or like 2 summers later, I worked at Google and built Cleanlab directly into Google's code base. A very simple version, different than what's online, but it was pretty cool. We were able to detect millions of label errors in their OK Google and Hey Google datasets. And it was just a great use case that we did prior to starting the company, which really showed us like, hey, this is something that can work in industry and at scale. And part of the motivation behind open sourcing it for other companies to use. If anybody has been involved at all in the data-centric AI competition, we also used Cleanlab there. And this was just a data set where you have a bunch of images that were sort of Roman numerals, and then we just ran Cleanlab, and what it does is it automatically will tell you like what's the most confusing example, what are the most likely errors in the data set. So this was an image that was labeled a VI, which is a 6, or that was the actual image was a 6, but the label was a 7. And we were able to do this a bunch. We were also able to detect like all the hardest examples. So this is something that it looks like a 3, it's labeled a 3, but the model that they provided in the competition was like very certain it was a 2, like almost 100% certain. So what we do is something that Cleanlab can do is give you like a quality score and a ranking over every example. So you can actually see which examples confuse your model the most, which are the hardest examples, and what are all the errors in your data set. And these are all things that you can automate with the open source and also with their SaaS product. So just a few sort of healthcare specific examples. So one thing it's really useful for is correcting insurance codes. And for here, I want to actually jump back to the open source. Let me just go here real quick and show you what that would look like. So you can go check out the open source, and you'll see some very simple code here where you can actually find label errors in one line of code. So I just want to walk through what that would look like. So say you have some insurance codes. Those are labels, like this is code 104 and this is code 115. And then you have the insurance description, which is a text. So what you would do is you would train a model, and you would use something called cross-validation if you're familiar, or you can just have 2 models, a training and sort of the other data set that you want to clean. And you would train on one. You can use whatever model you want. You can use some fast text, or you can use a transformer, and you get as output for every example predicted probabilities, and that you would feed right here into this function. And to get this function, you just do from cleanlab.filter, and then you import find label issues. And then you have all your labels. Those are just your insurance codes. and that's it. You just run it. You could actually leave this line off. If you remove this line, this will return you a Boolean mask that has true every time there's an error and false otherwise. And if you put this in here, it will actually rank all the examples for you with a score that tells you sort of how likely it's an error and the indice of the most likely error and then the indice of the second most likely error. And that's it. So it's really simple. If it was complicated, I wouldn't be as excited to share it. So that's it. That's the whole example. So that's how you would find sort of insurance code errors. For real-time assistance, it's very similar. So what we do is you have a pre-trained model we've already sort of done what I just showed you for insurance codes. But now every time there's a new example, instead of finding an error in all the errors in a data set, we just check for each new example, is it an error? And that's something we support in our SaaS product, but you could set that up with your like using the open source as well. And so that's a way, for example, if you had medical diagnoses, if you had a doctor who wanted to have a second check on their, say you have images of like, thyroid cancer, and you're just trying to detect, given that image, does this like likely have cancer or not? So you would want to have some kind of real-time double check, like, hey, does this actually seem like it has cancer? And that's something that you could set up using Cleanlab. And then finally, a previous company that I co-founded, it's called ChipBrain. What we did is we used Cleanlab to clean up a bunch of emotion data. So you can imagine all over the internet, there's like all sorts of, ways that people do emotions, people send smiley faces and hearts and all of this. And there's all sorts of data like that all over the internet. So you can imagine scraping tons of that, but it's really noisy. So like, how do you disambiguate between someone being frustrated and disappointed and angry and upset? They're very like sort of hard, even for humans, to disambiguate. So you can use Cleanlab and you can actually go through and find only the clean data, the sort of non-confusing, non-messy data. And that was one way that we were able to really train a much more accurate emotion detection system, which can be used for therapy, and you can actually use it for interpreting like sales calls and customer service. It's just generally and broadly applicable for anything that involves human emotion, therapy, and understanding people from sort of the more of the psych perspective. So those are just three examples. All of them involve forms of text, and also can be applicable to healthcare. It's just a good tool, and excited to share it with you guys. So given that we're running short on time, I'll speed up. I only have really two more things to share. One is that we have a beta sign up. This talk is intended to be about the open source, about what we've sort of given for free. And so I won't say anything more about it, but if you're interested, what it will do is you don't need to know any code, and it automates everything. It will rank your data for you. And I won't get into it. I won't make that be the point of the talk, but we're a company. Obviously, this is sort of something we do. We have a product beyond just open source, but I'll sort of not make that the focus of the talk. So finally, contributions. I shared a bit about labelers.com that you can check out and see how we can use Cleanlab at scale across all data sets. The open source, which I showed some examples of, and then the SaaS product you can email for an invite. And these are some old images. You can ignore those images. But the last thing I wanted to share is that we're hiring, and we're hiring for the open source. Looks like the image is not loading, which is fantastic. But yeah, we're building a pretty fun team, and we're contributing heavily to the open source. So definitely, if you're interested, please join us. And yeah, appreciate it. Check out Cleanlab. It's pretty cool. I think it'll be really relevant for everybody here.